and making sure that this all made sense. But I think I made this adjustment already, but I got to check it. All right. So, do we want to do another one? Really? You guys want to do another one? Hey, Smokey. Do more? Really? Okay. 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 I've got more. I've got more. But wait. I've got more. Okay. Let's do this and we will do this. We are going to start here. Can we see that? Smoking. Oh my gosh, it's like a little reunion. All right. So how do we do it? How are we doing? We've got user 979's got it going. How's it going? Oh, hello. So we have our hundreds and no cheating peoples. Yes. We have our tens and then we have our ones. Thank you, pretty girl. And then thank you 979 and what would you do? Yes. Oh no, what do you want? What do you want? Yes, thank you. So we have our hundreds, we have our tens, and we have our ones. We have 980. And it'll take us to here and then we do this. When we're done with this, we're going to go on to adding and subtracting because I don't want to be stuck just reading these numbers. We can do more, I tell you. But wait, there's more. So we have our hundreds, we have our tens, and then we have our ones. So if I have my hundreds, my tens, and my ones, what number do we think? Yes, thank you, user 979 and pretty girl. Thank you. Thank you. I really like that name, pretty girl. Okay, so we have 407. That's what 407 looks like, right? 407. And then takes us to here. Okay, we have our tens, our hundreds, our tens, and our ones. So we have our tens and our hundreds, our tens, and our ones. We have, thank you so much, 655. Thank you. Is it Ilira? Ilira. Is that Ilira? Is that how you say it? Or can I call you pretty girl? Okay, 655. Yes, 655. I like this. Oh, good. Oh, good. I'm happy. Okay, and then it takes us down to here. And what number? But we're going to do more. No, we're going to do more. We got to do some adding and subtracting. We got to do some adding, subtracting, and if we have time, we'll do some multiplication. But the first thing we got to do is understand how to read the abacus. Because there's more to it. There's just more to just the abacus than counting. My eyes are over here. So we have our hundreds, our tens, and then we have our ones. So we have our hundreds, our tens, and our ones. What number do we think that is? Yes, thank you. 149. Yes, thank you. 149. Maria. Oh, hey, Maria. Oh, dear. Okay. So then we have 149. It'll take us to here. It will take us to here. And then we have our hundreds, we have our hundreds, we have our tens, and then we have our ones. We have our hundreds, tens, and ones. Thank you. Thank you, Maria. Thank you, 979. Yes, right? 407. 1, 2, 3, 4, 0, 5, 6, 7, 8. Good. Well done. Trizzle. When we're looking at it, just hang out for a little bit. You'll get it. Because why? Simple to use, easy to understand. Simple to use, easy to understand. We just go through a little bit, right? When we're reading it, go ahead and try, Trizzle, what number this is. This is, how many beads do you see? How many beads do you see here? Right? Every column is a place value. And then what number do you see here? If we have our ones, our tens, and our hundreds. You should be a teacher in school the way you teach. Ha ha ha! Yes, thank you. 137. Thank you. Yes, it is. 137. Thank you so much, Maria. I appreciate that. 137. Trizzle. I don't know if Trizzle's still here. So we have 137. That's what it looks like. And then it takes us to here. So we have our numbers. We have our hundreds, our tens, and then our ones. So when we look, or maybe I'll move it up a little bit so you can see. We have our hundreds, 5, 6, 7. We have our tens, 5, 6, 7, 8. Good. Maria, thank you. Thank you, 949. Thank you, Maria. And then 3, 1, 2, 3. Let me color it in. I'm sorry, I forgot to color it in. So, Trizzle. Oh, there you go, Trizzle. Where did the 7 come from? 7 is here. 5, 6, 7. All the top beat is a value of 5. So when I look, this is 5. When I look, this is 1, 2, 3, 4, and then 5. We have 6, 7, 8, 9. Yes, thank you, Maria. The blue bead is always 5, right? Easy. 3, 7, 8. Okay, there we go. There we go. Okay, what are we doing? So we have our next number. Trizzle, what do you think this is? What do you think this is? Okay, we have our hundreds, we have our tens, and then we have our ones. So if I color it in, we have our hundreds, I'm on my tens, and then this is my ones. What number? Thank you, Cole. Yes, 146. Almost, Maria. Thank you, Heart King. Yes, thank you. Thank you, Torres. Thank you, T. Thank you, 979. Yes, 147. Because why? 140, 1, 2, 3, 4. I'm sorry, 6. 146. 5, 6. Yes, thank you. Thank you, Jeremy. Thank you, Jeremy. Jeremiah was a bullfrog. Did you ever get that? That's a very old song. I don't know how old you are, but it's probably like archaic for you. Ancient. Ancient. I was born in the 19th century. That's how ancient I am. All right, I'm sorry. Digress. I digress. So this is hundreds. This is our tens, and then this is our ones. So if I have my hundreds, my tens, and my ones, what number? Thank you, Trizzle. Yes, right? Easy. Thank you, Cole, 979, Torres, and Maria, right? So it's easy. You just sit around a little bit and you'll see it. You'll see it. Simple to use, easy to understand if you could see all the numbers, because I have to move the stuff around. Moving the stuff. Okay, so when we have our hundreds, we have our tens, and then we have our ones. So we have our hundreds, we have our tens, and then we have our ones. Thank you, user 979 and Cole, right? Thank you, Torres. We have 147. Yes, thank you. Why do we have this? Why? Yes, it's good, right? We have 7, 5, 6, 7. That's the one Chisel is having an issue with. All right, what are we doing? Oh, there we are. Okay, so how are we doing? Okay, we have 147. Takes me over here, and I'm over here. We're almost done. And then we're going to do some adding and subtracting. That's what we want to do. I want to go into adding and subtracting. It's more fun that way. Okay? So we have 100, right? My hundreds, my tens. Did I do this again? I did that again. Yes. All right. Yes, you can multiply. I got to do this one again. Okay. So what's our final answer? Yes, we can multiply. We can multiply, but let's put a pin in that. Boop. And what we'll do is we are going to learn how to add and subtract, and then after that we'll go into multiplication depending on the time. And it also depends on the class. So if I have my hundreds, my tens, this is my tens, and then this is my ones. So my, yep, 27. 27, right? Okay, we're done. We are done. We are done. Okay, 27. Great, everybody. Okay, so the first thing we're going to do now, no, not first. We already did the first. The first thing we did is we understand how to read the abacus. Now, what's going to happen is we need to understand how to move the abacus. Hello, Joel. Thank you. I appreciate being interesting. I hope I am. No, I'm kidding. Yes, the abacus is very interesting. And what we're doing is we're learning how to read the abacus and doing basic arithmetic. Basic like adding, subtracting, multiplication, and division. And so, almost, Sophie, you forgot the 0 in the middle. So it's 408. So when we're looking at it, very close, and thank you for participating. When we look, we have the tens, the ones, the tens, the hundreds. So when we ease your going, It can be from left to right, or you can go from right to left. It is up to you. This is the greatest thing that came up in my feed. Whoa, thank you, Jared. Sophie, Steffi, did that make sense? So when we're looking, we have 408. So you're very close, and yet, but we got to make sure that we have the zero as a place value. Okay, so the first thing we're going to do is understand how to move the beads. We already know how to read the abacus. We already read the abacus. Okay, great. So what we're going to do now is we're going to learn how to move the abacus. But the first thing we're going to do is understand, oh yeah, right, it's easy, right? Okay, good, that makes sense. Okay, good. So if you notice that the beads, right, have an edge, because they have an edge, you want to use your fingers to move the beads. So when I move the beads, I go 200, or I do 400. If I do together, I'd use my thumb, I just use the edge. So what I'm doing is I'm just showing you how I use the abacus with the edges. When we're doing abacus and we're doing math, you don't want to be aggressive, you want to be gentle. Be gentle. You want to move the beads gently. And so when we're doing it, right, we want to be gentle. We don't want to be aggressive, because what happens is when you're aggressive, your answers will be wrong. Like if you bump it, it will be very easy to bump, and the abacus will be wrong. I'm sorry, the answer will be wrong. So you want to make sure to stabilize the abacus with your left hand. And also, if I have a question, don't flick. Don't flick. What you want to do is you want to move the beads with intention. So if I have 9, I want to take away the 3. Ah, thank you, Elide. Thank you so much for the harmony. No, thank you. Elide. 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 I think I said that wrong. I hope I said it right. I hope so. Thank you so much for sharing. Okay, so what we're doing is we understand we're not going to flick. It's a pinching. Yeah, when we're doing the 2 beads, it is pinching. But when we're doing the 1 bead, right, it is the fingers. So with the thumb or with the finger on the top. So when we're looking, that was the flicking, that was the moving, and that's being happy, right? And so you might be asking, why am I here? Well, if you notice, I have an indicator. I have a notch. I have a dot. This is my ones indicator. If I choose here, just like a Pokemon, then these columns would be ones and tens. Then what happens would be my 1, 2, 3, 4, 5, right? And then 6, and then 7, and then 8, and then 9. And then this would be 10. But notice I have no more beads for the hundreds. So that's why I choose So that's why I choose here to my ones. So my ones would be over here. So now I have my ones, my tens, my hundreds, my thousands, my 10,000. 6, 7, 67. That's what it looks like. That's the greatest number because I can actually show it on the abacus. How do I get 67? 5, 6 on my tens, and then 7. 5, 6, 7. That's how you get 6, 7. So now you can show 6, 7 on the abacus. Would anybody understand? I'm not sure if they would understand, but those people that know the abacus would understand it. All right, so that's what is about. Oh, and then the other thing is if you notice that we have a decimal. This decimal here will help us keep the decimal places, so we can talk about the tenths and the hundredths, if that makes sense. So it's like, counting money. We can do our, 10 cents, 20 cents, 30 cents, 40 cents, and then 50 cents, right? Or we could do one penny, 2 pennies, 3 pennies, 4 pennies. Does that make sense? Hey, Brella. Ah, right? It's very elegant. It's very easy and elegant. It's so, like, I can't believe how this had made math so easy. I'm telling you, it's crazy how easy it makes math. But, we got to go through the understanding the fundamentals. We need to understand the fundamentals. So the first thing we're going to do is understand, in the abacus world, we need to know our add-in. That's what we do in abacus world. We need to know our add-in. Why? Because it's all about the journey, right? Abacus is life. It's about the journey. Life is a marathon. Abacus is the journey. We don't want to know the destination. We're not result oriented. What we're doing is we're process oriented. We want to, I was watching this one, no, I was reading this one book called the Toyota way, where they're talking about how to be efficient and all this and that. And they notice that the American factories are very result driven, just like they're doing with the math. But in abacus, and I'll show you why it's better to be process driven. Because here we have 5. When I have the 5, my question is can I add the 1? Yes, we can. Yes, we can. So we're going to add the 1. So my final answer is now 6. So what we're doing is we're understanding, can I add this number? That's the question. Can I do it? Do I have enough? And it's the same thing with the 2. When I have 6 and then I add the 2, can I do it? Yes, we can add the 2. So my final answer is now 8. We're not looking at how many ways we can do the 8. What we want to do is, can I add the 2? That's it. Can I add the 2? So the next one is 3. So you'll notice that when I add the 3, I have 5 and then I add the 3. Can I do it? Yes, I can do it. Now, in the mainstream world, what did you do? You do dots, right? I don't know. I don't know how you did it. I had to memorize what 3 plus 5 is. But in lately, right, they tell you how to do dots, and then you have to count all the dots. So you know how to count really well. But then in abacus, you can supertize. So what does supertizing mean? You can look at it and you'll know what the number is. So if I look at it, I don't need to count it out. I just need to be like, oh, that's 8. Why? Because I know this is 9. I know if I do this, this is 8. I do this, that's 2. If I do this, this is 7. So what we're doing is, what if we did 5 plus 5? Oh, that's a good one. Brella, can I put a pin in that? And I will answer that in a little bit. Because that's what happens when we critically think about when we don't have enough beads. So let me put a pin in that, if I can put 5 plus 5. And I'll answer that in a little bit. Because the first thing we need to do is we need to understand, it's Briella. Oh, okay. Good. Thank you. So when we're looking at it, we want to add the 4. When we add the 4, we take away the 4. When we add the 4, take away the 4. And it's the same thing. So you'll notice when I add the 4, I'm going to the horizontal bar. When I go away from the horizontal bar, that's a subtraction. So here's my question, as I want to add the 3. I'm adding the 3. When I take away the 1. So notice I'm moving away from the horizontal bar. Now we have 2. When we're looking, it's the same thing. We just need to look at the second number, right? The second number will tell us what we can do and what we cannot do. So we add the 3. I want to take away the 2. Can I do it? Yes. I want to take away the 2. When we look at it, right, my final answer is 1. And it's the same thing with the 3. Same thing. And what we're doing is we're just looking at how the beads move. So we have 8, right? We have 8, and I want to take away the 3. That's it. Right? Make sense? Okay, we did the 4, we can do the 4, we can do the 5, and the 5 is the same. So we add the 5 to the horizontal bar, we subtract away from the horizontal bar. If I have 1 and when I add 6, I pinch it just as what do you want from me? That 9, yeah, mentioned, and then you pinch away. I don't know what the opposite of pinching is. You push it away. You pinch and you push. So you add the 6, you take away the 6. You add the 6, take away the 6. And it's the same thing with the 7, 8, and 9. So we have the 7. If we have 1, we want to add the 7, we pinch it. We want to take away, we move it away. And then we do the same thing with 8. Oh, this is 9. And 9 is easy. Why? Because it's all together, and we take it away apart. We all together take it apart. And that's it. Cool? Okay, so, right. So before we go to what 5 plus 5 is, let's continue on understanding how to do more. Now, if you look, oh, that's right. So I need to here. Oh, I didn't add it. Oh, I know what I did. Okay, sorry. I was looking at this. And I need to do this. And I need to, where are we going to go right now? We're going to go to this bit. Okay. So you might be wondering, what are we going to do next? What we're going to do next is we're going to figure out how to add more. Because you only have so many beads. What are you going to do when we add more? This one, is about how to make a 5. When we make a 5 is what? Making the 5 is one of the critical things that we're learning in abacus. Now, in school, we teach the kids that we make a 5, but in abacus, we actually utilize it, and we want to make sure that there is no freeloading numbers. The next thing we're going to do is we're going to take this information and we're going to power it up. What does that mean? What happens is, what is the question? You're talking really nonsense. Let me show you. Let me show you. Let me show you the way. As long as you're open to new things, I appreciate everybody too. So let's start with the question here. 3 plus 4. So if I have 3 on my abacus, I have 3. These are 3 cents. If you notice, I have 1 cent. 1, 2, 3. 1, 2, 3. Because I have 3 cents, now what am I going to do? I want to add the 4. This is the add-in. This is where the add-in becomes very specific, right? So what are we trying to do? We are trying to understand, can I add the 4? No, I cannot add the 4. What do? I can, I have enough beads. I have enough money for 5. I have 5 cents. 5 cents. I'm going to give you 5 cents, but that's too much. So now I need to have an exchange. I need to have change back. So I'm just going to take away the 1. I can show you on the abacus. I can add the 5, but now I need to take away the 1. So my final answer is 7. Does that make sense? So what we're doing is we're understanding how to add with this 4. We can do it again. I'll show you another way. So if I have 4 and I want to add another 4, now in abacus world, we do not memorize what 4 plus 4 is. What we do memorize is this formula. The formula that I just did is doing some modification. We take this 4 plus 1 is equal to 5. We modify it. So what do? We isolate the variable. This is the variable we're going to isolate. We use it, right? We take the 1, we move it over here. It gives me the equation. If I have a 4 and I don't have, if I have a 4, it's the same as 5 minus 1. All right. So what happens is I want to add the 4. I'm going to use this formula, 5 minus 1. What do? 5, I have my 5, right? I give you my 5, but that's too much. I need to take away 1. I need the exchange. I need the change. So I can show you again on the abacus. If I had 4 on my abacus, I'm going to add the 5. When I add the 5, that's too much. I'm going to take away the 1. So my final answer is 8. So what we just did is we powered up our addition sentence. We talk about 4 plus 1 is equal to 5. Now, in abacus world, what we did is we actually utilized this concept to make it work for us. Does that make sense? How are we doing? We can do it again with the 2. So if I have 2 on the abacus, if I have 2 on the abacus, and I have the 4. But guess what? I have enough money for 4. I have enough money for 4. I have 5 cents. But if I give you my 4, if I give you my 5 cents, that's too much. What do? Thank you, Jared. What do? That's too much. I need to do an exchange. I need to get my change back. My change is 1. So I could show you on the abacus. If I give you the 5, I could take away the 1. So my final answer is 6. I like that one. Right? Does that make sense? We can do it again, but with a different number. We could do it with the 3, but notice the 3, the partner of 3 is 2. So 3 plus 2 is equal to 5. We could do the same thing. And we go to this question over here. Again, we're not going to memorize our doubles, right? Doubles is not what we want to do. What we want to memorize is this concept of 3 plus 2 is equal to 5. When we're looking, right? I have 3 on my abacus. I have 3 on my abacus. I'll have 3 pennies, 3 1 cents. I want to give you 3. Oh, the layers to the math. So what we're going to do is we're going to give you the 5. I'm going to give you the 5, but that's too much. So what's going to happen is I need change back. I'm going to take away 2. So I can show you on the abacus. I add the 5 and I take away the 2. What did I just do? Again, I powered it up. I had this concept. 3 plus 2 is equal to 5. I isolated my variable. My variable, which is a very algebraic terminology, right? Algebraic terminology. What we're going to do is we're going to isolate the variable. It looks very similar to, if I can write it, if I can find it, right? It looks very similar to x equals 5 minus 2. Looks very interesting, right? Looks very familiar. But we know what our variable is. So we're doing the beginning steps of algebra. So, oh yeah, and then what did we do? We substitute this information for the 3. Thank you. Call Malise. Call me, oh, call me Liz. Ha 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 ha. It's like another language to try to understand everybody's like username. Call me Liz. Yes, yes, thank you. Okay, so what did we just do? We're understanding concepts. We're understanding this, how to add the 5. So when this adding of the 5, we understood is the variable. We know how to do the 4. We know how to do the 3. We could do it again with the 2 and the 1. But these numbers don't have a lot of these numbers don't have a lot of questions to go with it. So what are you trying to say? Well, here, if you look, I have 2. When I have 2, I have 2 of my abacus. I have 5 cents. So I'm going to give you 5 cents, but that's too much because I'm looking for the 3. What's going to happen is I'm going to take away the 2. I could show you on the abacus. I can add the 5 and I take away the 2. So my final answer is 5. Now, what we're going to do is we're going to compound this concept. Let's do one more. Here's 4. I have 4. I don't have 4. I have 4. There we go. I have 4. I'm going to add the 2. Notice that when I add the 2, I don't have any more beads. I have no more single beads, right? I have no more single money. So what do? I do have 5 cents though. This is my 5 cents. I'm going to give you my 5 cents, but that's too much. I need to get change back. So I'm going to take away the 3. I can show you on the abacus. I can add the 5 and I can take away the 3. So my final answer is 2. That's it. That's it. So that's it. And then there's another one. Okay, so now what we could do is, if we're okay, we're going to go on to how to make a 10. And that was one of the questions. I'm sorry, I forgot who it was. How to make a 10, right? Huh, Briella, thank you. Yes, okay, good. So we're going to make a 10. Let's do a different number, right? We're going to do 5 plus 5, which is fine. We could do this one. These are all the partners, right? These are all the pairs that we have to make a 10. So what we're going to do is we're going to go to the next phase. Now, what does that mean? We understand how to make a 5. That was too easy. Okay, great. That's fantastic. Because now you understand the concept. Now what we're going to do is we're going to compound this concept. Hey, WWE, yes! I have been here since like 5 per life. Yeah, right? And look at me now. Hey, are you out of school yet? WWE? My kids are out of school already. They already graduated. All right. So this is the next one, which is, yes, ma'am. Ooh. What did your teacher think about my lessons? That was funny. That was hilarious. I tell everybody. I tell my kids about that, and they're like, this person even showed me to the teacher." That was funny. Okay, I need to. Oh, there it is. Okay, so what are we going to do now? We're going to do is a plus 10. Plus 10 is the same concept, but what's going to happen? Let's do 8. So I'm going to move over here. I'm going to add the 8. When I add the 8, we're going to know to have our formula, right? We know 8 plus 2 is equal to 10. This is what we're trying to do. What we're going to do is we're going to modify. When we modify, so this means I'm going to add the 10, take away the 2. When I add the 10, I think she should come take her spot. I graduate. Whoa, whoop, whoop, whoop. That's fantastic. 3.8. Well done. Well done. So here's the question. We have 9. If I have 9, let me give you my 9. I have 9 on my abacus, right? I have 9. 1, 2, 3, 4, 5, 6, 7, 9. 5, 6, 7, 8, 9. I have 9. Now I want to add the 8. But then when I add the 8, what happens? What happens? I'm going to add the 10. But guess what? I have 10 cents. That's more than enough, right? 10 cents for an 8, but that's too much. So what do? I need to remove 2 cents. So I'm going to give you my 10. I can show you again. I'm going to give you my 10, but I need to remove 2 cents. And so what I'm going to do, my final answer is 17. That's it. 17. Does that make sense? We can do it again. We can do it again. So let's do a 4. 4? Yep, let's do 4. Let's do 4. We do 4. We have 4. And then what are we going to do? We're going to add the 8. When we add the 8, I have 10 cents. Right? Thank you so much.
Welcome to the real.
So we're going to add the 8. When I add the 8, I have 10 cents. I'm going to give you my 10 cents, but that's too much. I need change back. So I'm going to take away the 2. I can show you on the abacus. I'm going to add the 10, but that's too much. I got to take away the 2. So my final answer is 12. Bada bing, bada boom. That's it. But that's what it is. So the question was to make a 5, right? 5 plus 5. It's the same thing. It's the same thing. So I do 5 plus 5. When we do 5, right? 5 plus 5. That would be easy. When we do 5, we want to add another 5. I have 5 on the abacus. I have 5 on the abacus. I'm going to add another 5. To add another 5, I don't have any more. I only have 4 pennies, but I have this nickel. I have this dime. When I have this dime, I'm going to give you my dime. I'm going to give you my 10 cents, but I'm going to take away this one because I need change back. So what happens? I'm going to give you the 10, but I need to minus the 5. So my final answer is 10. This makes sense, but has always baffled me. Can we do 3-digit numbers? Yes. Do we have other videos? Yeah, we could do it, right? So what we're doing is we could do 3-digit number, not a problem. Here we go. Are you ready? Are you ready? Hey, Michael, let me know when you count. If you have 283 fingers, let me know when you add 511 fingers to it. That'd be fantastic. But then you'd be a little like alien. I'm just saying. So here's our 3-digit number, and it's exactly the same concept, right, Jared? So the same concept is I have 283. When I have 283, the question is always, do I have enough? So my answer is what? Not my answer. My question is 5. Can I add the 5? Yes, I can add the 5, and I'm going to add the 5, right? So then I want to add the 1. Can I add the 1? Yes, I can add the 1. Can I add another 1? Yes, I can add another 1. Not a problem, right? So my final answer is what Mila said. Five's versions. Okay. What Mila said was 793. Yes, you can go up to 10,000 for this one. Thank you, Barella. Yes, thank you, Michael. 700, yes, thank you, 793. And then when we're looking at it, right, let's do it again. We can do 2-digit. When we do 2-digit, the concepts are still the same. So we have 26. When we have 26, we want to add 32. When we add 32, guess what? What's going to happen? I can see, and it worked out. Yes. So here, I want to add the 3. When I add the 3, guess what? I don't have any more beats to add the 3. This is where the fundamentals happen, right? I want to add the 5, take away the 2. And then can I add the 2? Yes, I'm going to add the 2. So my final answer is 58, right? How does adding 1 to 3 make 3? Oh, sorry, Kit Kat. I said that wrong. Okay, so here's another example. Jared, here's another example. If I have 578, right? And then I have 24,311. 20. Add the 2. Can I add the 2? Yes, I'm going to add the 2, right? I want to add the 4. Guess what? I don't have any beats to add the 4, but you know what? We know how to do this. And I showed you. If I have 3 on my abacus and I want to add the 4, right? I have the 5. So what's going to happen is I add the 5 and I take away the 1, right? And then the question is I add the 3, and then I add the 1, I'm going to add the 1. I add another 1, and I have that. So my final answer is, thank you, Michael, 37,889. Yep. right? Does that make sense? So it becomes scalable. What we're doing is I'm showing you the basics on how to move the beads, how we use the abacus. And then the next thing is to start, having bigger numbers, if that makes sense. So the bigger the number is, the bigger the number, it doesn't matter. It doesn't matter what the numbers are now because we know the fundamentals. That's why I show you this. I'm a genius. That's great, Michael. So does that make sense, Jared? We're okay? So, and then we can keep going with this. Yeah, no, that's a really good question. And sometimes we get stuck with the single digits, right? But when we start understanding that this becomes bigger, then it's a lot easier. It's a lot easier to see how it relates to it. But usually the kids, when they do it, they're, usually young. Not too many adults, only that have gone through my lives are they asking these questions. And abacus is usually not introduced at the older age, but I'm going to change that. All right. So that is adding the 10. Does that make sense? What we did is we learned how to add the 10. We could do it again with the 9. So here's my question. I have 4, right? I have 4. I'm going to add 4. My add in is 9. When I want to add the 9, what do I do? What do I want to do? I need to utilize this concept. This is the addition sentence. 9 plus 1 is equal to 10. So what are we going to do? We're going to modify it, right? We can modify it, and our subtraction is what? Our equation is what? Our formula is what? 10 minus 1. You can rewrite it minus the 1 plus the 10. And if you look, we're going to plus the 10 minus the 1. When we do plus the 10 means what? 1, 0. 1, 0. We're going to add the 1 and add the 0. And then we need to minus the 1. When we minus the 1, we take away the 1. My final answer is 13. Kids who use an abacus tend to have high test scores than the ones who use calculators. Yeah? Because they have a stronger number sense. The calculators don't tell you how to do things. But you know what? You're calculating this in your head. We're just using the abacus to move the beads and to track the numbers, if that makes sense. But it was very interesting. My boys, I have 3 boys, and they all gone through the abacus curriculum. And when they start going into algebra, they're like, I know this, but I don't know why I know this. Because there's a lot of algebraic elements in abacus. For example, what we do is we isolate the variable or we substitute the information, right? So here's the question. If we did 9, we have 9 and we add another 9, what are we going to do? We know that we need to substitute plus the 10 minus the 1. Ah, thank you, Jared, for the rose. Thank you so much. So does that make sense? So we're going to substitute plus the 10, 1, 0, and then we need to take away the 1. We will take away the 1. So my final answer is 18. Sometimes it takes me a little bit to read the numbers, but that's the difference between presenting and just doing it, right? Ones and the tens and the minus the 1. Yes, exactly. The ones, and that's the thing, right? This 10, this 0 right here is a placeholder. That's the crazy thing. It's a placeholder. So it actually gets better. It seems a bit more confusing for me. Mila. Well, I don't. How long have you been here, Mila? Because I've been on for about an hour, so I started from the beginning. If you're here for an hour and it was confusing, then I can understand. But if you're only here for like 2 minutes, then yeah, see, yeah, yeah, there's a precursor to everything. So, but before I go to that, before we do a review, let me continue with my thought about this 10, which is really quite interesting because now what we're doing is we don't want to look at the 10 as the place value. So if the number was here, if we said 9 plus 1, if I said 900, I need to write it out. If I said 900 plus 100, let's say, right? Just for whatever, right? If I did 900, when I say plus the 100, I'm not going to say 10,000 plus minus 100. I'm not going to say this. All I'm going to say is this. Plus 1 is equal to plus the 10 minus 9. So what am I going to do? I'm going to plus the 10. I only look at the column. I only look at the column like this. I want to plus the 9 here. I'm sorry, I plus the 1 here. To plus the 1, it's plus the 10 minus the 9. Plus the 10 minus the 9. So I'm going to plus the 10 and I take away the 9. So then my final answer is 1,000. So when we're looking, what do you want from me? What we're doing is we're understanding, right, that it doesn't matter where you are. You just need to know the fundamentals. This is bite size, right? And we don't need to do this. We don't need to do the whole thing because why? This is what happens in new math because they use paper. Whereas in abacus, abacus tracks your number. So you don't need to do 100 minus 1,000, 1,000 minus 900. You don't need to do that, right? Does that make sense? So what happens is you take it bite size. That's why we talk about the basic and we understand the fundamentals. Does that make sense? What do you want from me? Okay. Okay, good. So let's do a review. Thank you, Mila, for letting me know that you're here. Okay, are we ready for the review? We're going to do a review. This is an abacus. The abacus is a counting tool. And what I was just doing, I only think about the numbers, not place. And I was, yes, only think about the numbers itself. So that's why this is really critical, right? If you look, when I said it, 1, 3, 5, 7, 8. When we added this 4, remember we added the 4. It was very specific to this column. It didn't matter about everything else. It only mattered about this column to add the 4. Did that make sense? So when we add it, can I do it? Yes, I want to add the 2. Can I add the 4? Yes, plus the 5 minus the 1. We did this before. And then what? Plus the 3. Can we do it? Yes. Add the 3, add the 1, and then add another 1. Just like in regular math. Mainstream math, we do it this way, right? We do 1, we do 8, we do 7. I'm sorry, we do the 5 and the 3. Then we do the 3 and the 4. And then we do the 2, 1 and the 2. Same thing. Same thing. But it's interesting because in abacus world, we do it line by line. So if I had another set of numbers, if I had 5, 6, 7, 8, 9, right? I don't do this in abacus world. What I do is the whole number, and then I do the next whole number. That's an example. Okay, so let's do a review for Mila. Mila, are you still here? Let me know. Because if not, I'm going to continue forward. Mm. Great. Each color is the number. Oh, almost. However, great, Mila. It doesn't matter what the colors are. It's just there for being pretty. So what we're going to do is we're going to review. Let's do a review. So we have 1, 2, 3, 4. When we look, every place value, right? Every column is a place value. A column is a place value. So we have 4, and then we have 5. This is 5. Now we have 6. Notice if I add the 5, the top beat is 5. I have 6. If I have 2, that's just 2. I add the 5. Now I have 7. If I have 3 and I add the 5, now I have 8. If I have 4 and I add the 5, now I have 9. This one is a 13 column abacus. This is made out of plastic and it's very easy to move. So if you bump it, your answer will be wrong. So you need to use your left hand to stabilize the abacus. So after 9, right? What's after 9? Exactly. After 9 is 10. 10 is a 1 and a 0. 1, 0. So that's what it is. Whatever we However we write is how we read the abacus. That's it. That's it. Simple. Simple to use, easy to understand. Thank you, Mila, for following. Does that make sense? So the way we write is the way we read. When we have this, so let's do an example, right? We can do 1, 3. We could do it the other way. We could do 8, 7, 5, 3, 1. And then we could do 2, and then we had our formula plus the 5 minus the 1. Add the 3, add the 1, add the 1. Yep, easy. Hey, thank you, DLW. Okay, so what are we doing? How is it going? Are we all right? Makes sense? So what we're doing is we're understanding the abacus. And what's the difference is they're just, because size matters. This is 12, this is 13 columns. This is only 7 columns. This is a 7-column abacus. They work exactly the same. It doesn't matter. Now, if you look, the reason why I have this one is because it's pretty. And I usually teach the kids younger that are 3, 4, and 5. 6, yeah, you could do it with 6 because they like the colors. But then after they get to the bigger numbers, then I would suggest to use the 13 column. Then you can graduate them to the bigger abacus because they like to wear big people shoes. Just like they wear big people shoes and big people clothes, they like to have big people abacus. So yes, and it's interesting because what abacus does is it provides visualization on the numbers, and you could see your restrictions. And that's the interesting thing about it, right? You know, if you have enough numbers, if you have enough numbers to add the two. And what we're doing in abacus world is we understand what the add-in is. We don't need to know what the result is. We need to know what the add-in is. No, 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 no. God did it first. We do not call ourselves that. No, 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 no. That is not here. What we do is it is unfamiliar. Does that make sense? But you just got here. I've been on for an hour. You just got here. How do you compare me being here for an hour and you just being here for 5 minutes? Come on! No, 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 no. You're unfamiliar, right? We want to be careful with the words we use. We don't want to use that. Garbage in, garbage out. Do not use those words. I do not accept it. What we're going to do is we're going to review again and we will go forward, right? So, what we're going to do is we're going to count 1, 2, 3, 4. And then what do we do? This is 4. Anytime the beads are touching this horizontal bar, it is being counted. We have 4. When we do 5, the top bead always has a 5. The top bead has a value of 5. We can do it again. Let's do it in a different way. Let's do it with money, 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 money. Okay, so we have 1 penny. I don't know where you are in the world. This is 1 cent. This is 2 cents. This is 2, right? This is 3. This is 3. This is 4. This is 4. So we're done with this. Now what happens to 5? 5, you need to remove, and this is 5. That's like a nickel. This is like 5 cents, right? 5 cents. That's what this is. Then we do 6. So we do 6. We do 7. We have 7. We do 8, we do 8, and then 9, we have 9. That's it. So then what is 10? 10 is a 1 and a 0, just as how we write. When we write 10, we write 10, 1 and a 0. 1, 0. That's it. We have 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and then we have 20. There we go. 20, and then we can count, right? 20, 21, 22, right? Or we go hundreds. We have hundreds. We have 100, 100, 200, 200, 300, 300. And it's exactly the same. So if you notice, if I did this, this is 900. But guess what? This is 9. But it doesn't, the only thing that's the difference between this and this is the place value. And when we're looking, every column is a specific place value. Why? Well, if I look, there's a dot. There's a dot. This is a ones indicator. I could choose this one or I could choose this one. It doesn't matter. You just need to choose one. So if I chose this one, then this would be my ones. I would label this as my ones. I'd be like 1, 2, 3, 4, 14, 24, 34, 44. But then what happens is what? I don't have any room for hundreds. So then I go back. Okay, then I go back to here instead because now I have more room. I have more columns to utilize. So I have my ones, my tens, my hundreds, my thousands, my 10,000. It reminds me of unit blocks they would give us, but it's more structured. Exactly. But you know what? I have unit blocks. And the other thing about unit blocks is that it gets unruly. So these are the unit blocks, right? So we have this, but guess what? You would have to count it. You still need to count. So if I give you all of this, I'm like, I don't know how much this is. This is 1, 10, 20, 30, 40, 50, 60, 70, right? This is 70. I was like, oh my God, I had to count it. I'm like, what? If I do that, that's 70. Right? That's the difference. The difference is it's easier to see. It's easier to supertize with the abacus. I just learned tables. Can we learn tables, addition, subtraction, and multiplication? We just learned. Oh, yeah. Yeah, the interesting thing about it is abacus, you can see the pattern. But in mainstream math, you don't see patterns. Hi, hey, Taylor. How's it going? Yeah, right? And so that was the thing. Oh, way back in the day, this is way easier. Oh, I know, right? I didn't learn the abacus when I was a kid. When I learned it, I was forced to learn it because my dad wanted a learning center. And he's like, we're going to teach abacus to kids. And I'm like, oh, okay. But I'm like, why are we teaching abacus? What is this crazy thing? And I was really old when I learned it. And then when I started going through the process of learning abacus, I realized that it's a lot easier to do it this way because you don't need to memorize what 5 plus 5 is. You need to memorize the concept of how to make it. Then I go through, when I talk about abacus, I talk about why are we doing it and how we do it. So the biggest thing is understanding, right? The biggest thing to understanding is the concept of critical thinking. Do I do it? How do I do it? I'm doing really good. I'm very surprised that there's still 76 people in my room. Usually there's like 4 of us, 5, right? But I appreciate people are here and they're open to new things. And I appreciate all the comments and the questions. And that's the thing, right? Yeah, I know, right? Right? It was I mean, we did a lot more, but it was really quite interesting to see the progression and how everybody's just really interested. And it's kind of amazing. And I do feel like that this is the greatest thing next to sliced bread because it makes looking at the numbers way easier than what we have in regular math. Why? Because in mainstream math, we write it out. I'm 27 years old. I'm staying. That's funny. I'm intrigued. Oh, that's interesting. Yeah, I have books. I've got books and I've got jokes. I also have an online class which is going through it at a self pace. But what I'm here is I'm just here to teach you guys how to add. How to add. That's what it is. Add with the abacus. Why is the abacus the greatest thing? This is why. Am I a teacher? I am now, Kurt. Right? And that's the thing. That's the difference between understanding and providing knowledge. It's like finger counting, but more fingers. It is kinda, but it's more structured and what? It's more versatile. So we can actually do multiplication now. Oh, but Mila, we need to understand how to make a 5. So one of the things we understood is how to make a 5. When we make a 5 is what? When we have the question 4. Now the question is, now let me go back a little bit. Let me take back a couple of steps. So, why are we doing this? Well, the questions is 3. Again, what we're doing is we're understanding the add-in. When we understand the add-in, we don't want the result. We're not about the result. What we're learning is about the add-in. Yes, we're going to drop, but the problem is what? If I give you 5, if I have 3, if I give you 5, that's too much. So I'm going to expect change back because I'm looking for 4. So I want to take away the 1. So if I have my abacus, I have 3 and I can repeat it. I can add the 5 and take away the 1. So now we're balancing the equation. Does that, yeah. Okay, good. So that, yeah, drop the blue for the 5. Yes, exactly. And then we have to take away the 1 because we need to balance it, right? We can't just keep it here because it's not balanced. It makes sense when we start doing it again because now we have a concept and we have a concept and now we're compounding this practice. We're practicing. We have 4 on the abacus. I have 4 on the abacus. I want to add the 5 because I have enough money. But I have it in a 5 cents. I need change back. So I'm going to take away the 1. I can show you again on the abacus. I add the 5 and I take away the 1. And that's it. So what we did is this is a core concept. And that's why I was showing you this right here. That's what this was. It doesn't matter where we are in the place value of the numbers, as long as you know what you're trying to do. It becomes right. It becomes position agnostic. We need to understand the fundamentals. I don't know if anybody's watched Karate Kid, new one or old one. Old one is wax on, wax off, paint the fence up, paint the fence down. The new Karate Kid is what? Take a jacket off, take the jacket on. And it's the same thing. The same thing. We're doing the fundamentals. But then once you get there, right? What is it? It was, if you skip steps, you're going to be delayed down the line, right? You want to go slow to go fast. So what we're doing is we're going slow. We want to understand this, and then we will go fast. I'm old, like wax on, wax off, right? Yeah. Oh, so then you should know this one, right? God did it first. You should know this one. What movie did that one come from? Okay, so then it's again the same thing. But don't forget, now we're looking at pairs. The pair is what? The pair is two. So we have this concept. We have a fact family concept. What we're doing is we're going to power it up. We do modifications so we don't have freeloading numbers. I don't remember. I said I was old. This is old. This one, this one came from Arnold Schwarzenegger, Total Recall. Yeah, right? Yeah, Total Recall with Arnold Schwarzenegger, not Colin Farrell. Is it Colin Farrell? It's not the new one, it's the old one, right? Ah, I'm old. I'm old. Yeah, that would be the that would be the what do you call it? The test. All right. So again, what we're going to do, we know, right? We know 3 plus 2 is equal to 5. This is a concept, right? And again, it's the same thing. We have 3 on the abacus. We have 3 on the abacus. I want to add 3, but I don't want to memorize. I don't need to memorize. Yeah, I know, right? Yeah, it's no joke. That's no joke. Okay, anyways, so when I add the 5, I'm going to take away what? This is too much. I need to take away the 2. So I can show it again on the abacus. I add the 5, and then I take away the 2. Yeah, I know. Me too. Okay. So the story. So my background is I've been teaching abacus for 20 years, and I really think it's the greatest thing next to sliced bread. I have a bunch of abacus worksheets. I have abacus online classes, and I also provide tutoring to only abacus. We only do abacus. We're doing arithmetic, adding, subtracting, multiplication, and division. I learned how to do the abacus when I was 30. So you do the math there. And I was actually kicking and screaming, why are we learning this? This doesn't make sense. But then as I understand the process and the methodology of abacus, I feel like it is way better than mainstream school. And so I taught my 3 boys, and my 3 boys all know how to do the abacus. Can they teach you? Yeah, maybe. Maybe if they like understood it, they could teach you, but it's so ingrained. This concept that they have, they know how to use the abacus, it's very ingrained. So it becomes kind of second nature to them. Like riding a bike. Somebody asked me, well, with the finger movements, is it going to be easy? And I'm like, yeah, it's like, when we're typing on the computer with our keyboard, it's the same thing. My body says different. I know, right? My eyes. No, it's not my body, it's my eyes. My eyes says different. I'm like, oh my God, I can't see. Anyways, so like typing, right? When we're typing on the keyboard, we already know where that is. It's the same thing with the abacus. You do it enough times, it's like practice, right? It's you do it enough time, it's practicing. Daisy's mama, right? Thank you. So if you have any questions, let me know. What we're doing is we're understanding how to make a 5. That's what one of the books are. The books is to understand how to make a 5. Oh, and I'm going to have muscle memory. It is muscle memory, but it's also understanding how to read it too. You'll be able to visualize the numbers in your mind. All right. So before I go, I'm going to continue on with this concept with the 5, with the 10. So what we're looking is we're understanding how to make a 10. The concept is the same. We have 4 on the abacus. I have 4 on my abacus, right? I have 4 on my abacus. One, two, three, four. I have 9, but guess what? I have 10 cents. Because I have 10 cents, when you taught the placement, it clicked. Yeah, right? When I have 10 cents, I'm going to give you 10 cents. But that's too much because I'm only giving you 9. So I need change back. Because I have change back, my answer is 13. I can do it again on the abacus. I can show you. I add the 10, but that's too much. I need to take away the 1. Yes, thank you. Thank you. What would you do? Yeah. What do you want from me? Yeah, right. Thank you. Thank you, Mila. Right? I'm telling you. So so that's what it is. Making sure that we understand how to do things. So that's what the place values are, right? Cool. And it's very easy. And people who are not open to it always say that it's more complicated, but it's like I would rather understand why we're doing it than to memorize. Oh my god. So I was watching this one documentary about the truth about reading, and there was a lot of people that when they said they didn't know how to read, what they did is they started memorizing things. And obviously they didn't if they didn't know how to read, they didn't know how to like make words and stuff. And I'm like, these are like really big people. They're like, financial directors and all this and that, and they didn't know how to read. And I'm like, how do you get to a position that high, right? And what they did is they memorized like certain words, and they knew how to like memorize some words. And I'm like, oh my God, that is so crazy. And that's what it is. So doing the old way, right? Doing the memorizing way is very different than the abacus way. So that's what makes it like it really blew my mind. It's like that's we're teaching when I was young, we were teaching the kids to memorize as opposed to, right? As opposed to understanding the concept. It's interesting memory, right? Oh my god, this is not by this is a concept, but this concept we need to understand. And then when you understand this, you will be able to you'll be able to understand higher math. Abacus is the gateway to complex math. Abacus provides a foundation, right? Class is in session. Oh wait, I'm tuned in. Hello. I'm sorry. Abacus provides a foundation, a solid number sense foundation, and you will be able to scale this to as many numbers as you need. And then what you do is you go into adding a multiplication and division. Yeah, it's crazy. It's fantastic. I was like, it's interesting to see the difference between math and reading. And reading, they were having the same problems. They're doing more phonics and phonetics and balanced literacy and all this stuff. They had this whole like reading war, which is fine. But I noticed in math, we don't have that. Well, our problem is we have old math, common core math, and new math. But in the abacus, it tells you why. It's interesting. In new math, they tell you like how to write it out on a piece of paper, but they don't show you how it's being done. They give you these number blocks, but don't forget these number blocks are like crazy. They're like crazy too much. If I have more, it's like that's a lot of counting. And then you have to do grouping and regrouping. And I'm like, this is crazy. Whereas on the abacus, we can see it and we can supersize. That's it. So thank you, Daisy's mama, right? Welcome, welcome. I plead the thrift. I love thrifting. Yep. Are you on daily? I am on daily. I'm on daily and sometimes twice. Um, those are, oh, I don't know if WWE is still here, but yeah, I've been on for a little bit, but yes. Oh, I am on daily as much as I can. Perfect. I'll be back. What times? I'm trying to be consistent. I'm trying to do 8 in the morning and 8 Pacific Standard Time. Yeah. Tonight I'll try to go on Pacific Standard Time, but it all depends on like family obligations. But yes, thank you everybody for joining. I do appreciate you being here, and thank you again. I do have books if you're interested. I also have abacus if you're interested as well. And it's the greatest thing. I'm in Texas. Oh, cool. Oh, last night was crazy. It was like 3 in the morning for a lot of people, and they were still learning how to do math. It was the craziest thing. And it was like 50 people. I'm like, you guys are nuts trying to learn math in the middle of the night. But it was so funny. Thank you, Mila. Thank you so much for being patient while I walk through my thoughts and stuff. But thank you for being patient with me. I appreciate that. But you can't tell me that you don't understand if you've only been here for like 2 minutes. But I'm telling you, it's easy to use and simple to understand. It's just, it takes a little bit, right? Yeah. You'd make an investment, and that's it. That's right. I'm telling you. That's why sometimes I get a little salty when people are like, I'm so confused. Right? I'm telling you. Oh yeah. It's so funny. People are like, I'm so confused. Like, wait, hold your horses. Hold your horses. Okay, you have a good day, Mila. Thank you so much for coming by. I will see you in my next live. All right, math has always been my favorite subject, right? Ooh, you know, math was okay for me, but then again, I didn't learn abacus until way later. My abacus has been my favorite subject. Yeah. Thank you. Bye, Mila. Okay, so thank you. Bye, Daisy. Thank you, everybody, for joining. Thank you, everybody, for joining. If you have any questions, if not, go ahead and follow me, and you'll catch me in my next live, and we can answer your questions about abacus. Yes, thank you, thank you. Anybody have? So these are the questions. I have this and this in the abacus store. If you're looking for more books, I do have it here. My name is Lynette. Thank you, everybody. Hey, Cookie, welcome back. My name is Lynette. I've been teaching abacus for 20 years. Thank you, everybody, for joining. I do appreciate the support. I do appreciate being able to teach you and showing the new world. The
Welcome to the
Thank you for the real world, right? Welcome to the real world. And I think abacus makes math so much easier. Thank you, everybody, and I'll see you all in my next live. Bye. Ah, thank you, Daisy's mama, for the heart puff. I see that. Thank you so much.